Installing a manual transfer switch involves several important considerations. Firstly, overcurrent protection is essential. You need to have a means of overcurrent protection before the transfer switch. This overcurrent protection device must be rated for the maximum service ampacity of the meter. This is typically a main breaker or fuse located at the meter base. A service-rated transfer switch is designed to withstand the short-circuit currents associated with the service entrance point. However, this does not eliminate the need for overcurrent protection before the transfer switch. Secondly, bonding is necessary. You need to bond the neutral and ground in the transfer switch. This is because the transfer switch connects the house to either the utility grid or a generator. The neutral and ground must be bonded to ensure proper operation of the electrical system and safety. Thirdly, you should treat the main panel as a subpanel if you install a transfer switch. This means separating the neutrals from the grounds in the main panel. The transfer switch will serve as the primary service equipment while the main panel becomes a downstream subpanel. When you are treating the main panel as a subpanel, you need to isolate the neutral and ground. The neutral should land on the neutral bus, and the ground should land on the ground bus. These buses should not be connected, as they are in a main panel. In the transfer switch, you will bond the neutral and ground. This is because the transfer switch is now serving as the main service disconnect. Several additional considerations are important. Check with your local electrical code requirements to ensure compliance. Hire a qualified electrician to perform the installation. Install a generator interlock to prevent backfeeding the grid when the generator is operating. Backfeeding the grid is dangerous and illegal. A generator interlock prevents the generator from energizing the utility lines. This is typically achieved through a mechanical device that only allows either the main breaker or the generator breaker to be on at any given time. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. Article 702 covers optional standby systems, which includes generators used in residential applications. NEC Section 702.4 discusses the transfer equipment. It states that the transfer equipment shall be suitable for the intended use and be so designed and installed as to prevent the inadvertent interconnection of normal and alternate sources of supply. This means that the transfer switch must be rated for the voltage, current, and frequency of the system. It must also prevent the generator from being connected to the utility grid at the same time. The overcurrent protection required before the transfer switch protects the switch and the downstream panel from overloads and short circuits. The size of the overcurrent protection device should be based on the ampacity of the service entrance conductors. The service entrance conductors are the wires that run from the utility meter to the main panel. Their ampacity is determined by their size and insulation type. The NEC provides tables for determining the ampacity of conductors. For example, NEC Table 310.16 provides ampacity values for insulated conductors rated up to 600 volts. It is important to use the correct ampacity values to ensure that the overcurrent protection device is properly sized. If the overcurrent protection device is too small, it will trip unnecessarily. If it is too large, it will not protect the equipment from overloads and short circuits. When bonding the neutral and ground in the transfer switch, it is important to use the correct size bonding jumper. The bonding jumper is a wire that connects the neutral bus to the ground bus. The size of the bonding jumper is determined by the size of the service entrance conductors. The NEC provides tables for determining the size of bonding jumpers. For example, NEC Table 250.102. C1 provides bonding jumper sizes for service conductors. It is important to use the correct size bonding jumper to ensure that the neutral and ground are properly bonded. If the bonding jumper is too small, it will not be able to carry the fault current. If it is too large, it will not provide any additional benefit. When treating the main panel as a subpanel, it is important to remove the bonding jumper between the neutral and ground buses. This bonding jumper is typically located at the main breaker. Removing the bonding jumper ensures that the neutral and ground are separated in the subpanel. This is important because the neutral and ground are already bonded at the transfer switch. If the neutral and ground were bonded in both the transfer switch and the subpanel, it would create a parallel path for neutral current. This can cause nuisance tripping of ground fault circuit interrupters and can also create a safety hazard. When installing a generator interlock, it is important to follow the manufacturer's instructions. The generator interlock should be installed in a location where it is easily accessible. It should also be labeled to indicate its function. The generator interlock should be tested regularly to ensure that it is working properly. When operating a generator, it is important to follow all safety precautions. The generator should be located in a well-ventilated area. It should not be operated indoors or in an enclosed space. The generator should be grounded to prevent electric shock. The generator should be inspected regularly for any signs of damage. If any damage is found, the generator should be repaired before it is operated. The transfer switch should be operated according to the manufacturer's instructions. The transfer switch should be switched to the generator position before starting the generator. The transfer switch should be switched back to the utility position after the generator has been shut down. It is also important to consider the load in the generator. The generator should be sized to handle the expected load. The load should be balanced between the different circuits. Overloading the generator can damage the generator and can also create a safety hazard. Consider the specific requirements of your local electrical code and utility company. Some jurisdictions may have additional requirements for generator installations. Contact your local electrical inspector or utility company for more information. Remember to always prioritize safety when working with electricity. If you are not comfortable performing the installation yourself, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent electric shock and fire. Using appropriately sized conductors is important. The size of the conductors should be based on the ampacity of the circuit. The NEC provides tables for determining the ampacity of conductors. For example, NEC Table 310.16 provides ampacity values for insulated conductors rated up to 600 volts. It is important to use the correct ampacity values to ensure that the conductors are properly sized. If the conductors are too small, they will overheat and can cause a fire. If the conductors are too large, they will not provide any additional benefit and will simply cost more money. Using the correct type of conduit is also important. Conduit is a protective tube that is used to enclose electrical wires. The type of conduit that is used should be based on the environment in which it is installed. For example, PVC conduit is suitable for use in wet locations, while EMT conduit is suitable for use in dry locations. It is important to use the correct type of conduit to protect the wires from damage. Using the correct type of fittings is also important. Fittings are used to connect conduit to boxes and other electrical equipment. The type of fittings that are used should be based on the type of conduit that is used. It is important to use the correct type of fittings to ensure that the conduit system is properly sealed. Grounding is a critical safety measure in electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electric shock. The grounding system should be installed in accordance with the NEC. Bonding is also important. Bonding is the process of connecting all metal parts of the electrical system together. This helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. The bonding system should be installed in accordance with the NEC. Surge protection is a valuable addition to any electrical system. Surge protection devices, or SPDs, protect sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD should be installed at the service entrance and at any subpanels. Arc fault circuit interrupters, or FSIs, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are a type of electrical fault that can cause fires. FSIs are required in many areas of the home, such as bedrooms and living rooms. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults are a type of electrical fault that can cause an electric shock. CFCIs are required in wet locations, such as bathrooms and kitchens. When selecting a generator, it is important to consider the wattage requirements of the appliances and equipment that will be powered by the generator. The generator should be sized to handle the total wattage load. It is also important to consider the starting wattage of some appliances and equipment. Some appliances and equipment require more wattage to start than they do to run. The generator should be able to handle the starting wattage of all of the appliances and equipment that will be powered by the generator. When selecting a transfer switch, it is important to consider the amperage rating of the service entrance. The transfer switch should be rated for the same amperage as the service entrance. It is also important to consider the number of circuits that will be connected to the generator. The transfer switch should have enough circuits to accommodate all of the circuits that will be connected to the generator. When installing a transfer switch, it is important to follow the manufacturer's instructions carefully. The transfer switch should be installed in a dry location. The transfer switch should be properly grounded. The transfer switch should be labeled to indicate its function. Proper labeling is essential for safety. All electrical panels and equipment should be clearly labeled to identify the circuits and functions. This helps to prevent accidental disconnections and ensures that the correct circuits are de-energized during maintenance or repairs. Regular inspection and maintenance of electrical systems are crucial for safety and reliability. Electrical panels should be inspected regularly for signs of damage, such as corrosion or loose connections. Circuit breakers should be tested to ensure that they are functioning properly. Wiring should be inspected for signs of wear or damage. Any problems should be repaired promptly by a qualified electrician. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date in the latest codes and regulations to ensure that your electrical system is safe and compliant. Consult with a qualified electrician or electrical inspector if you have any questions or concerns. Installing a manual transfer switch is a complex project that requires careful planning and execution. By following these guidelines, you can help to ensure that your installation is safe and compliant with all applicable codes and regulations.